Okay, so my name is Irina Truong. I'm a software engineer. I've been a software engineer for about 20 years now, and I'm going to be talking about creating and publishing a Python package. You don't really need to know much Python for this. There's going to be some code on the slides, very easy to read. You still going to understand what's going on, and you can even follow along and create your own package. But you need to know, you need to have a working interpreter on your machine. So just two things that you're going to need: Python interpreter and the pip package installer. Let's talk a little bit about Python packages. Mostly, when we talk about packages, we think about libraries. A Python library can be installed on your machine, imported in your environment. It usually has some sort of a version, usually numeric version, but there can be different types, and there can also be different tools for automatically versioning your packages. Libraries are targeted to developers. Developers are the end users of the libraries. They are going to specify this library in their requirements and use it to actually implement and deliver some sort of application or another library. An application is very close to the library. It has everything that the library has, but it also has a runnable entry point. Sometimes it has multiple entry points. An application targets end users. And when we're talking about Python application, the type that I'm going to use here is a console application. It runs in your terminal. But there can be a web application, there can be a GUI application, so there can be all sorts of different types of applications. A console application is something that looks like this. So I have a few here. One of them is just a terminal. The other one is Midnight Commander, and the third one is HTOP tool. All of those are console applications. We are going to create a tiny little application that gives you advice. So it says today is good for something, some sort of activity. So let's write our function. And this is the whole thing. I'm importing a couple of packages in here, a random package to help me pick a random activity out of the list, and daytime. And that's the whole thing. It returns a string that says today is good for some activity. You can extend the list of activities to do whatever you want to do. Then we need the main function that will actually call our function and print the message. And the way we run this is Python, name of the file, and it outputs the message. So how could you share this code? Like if you wanted your friends to run it, if you wanted your family to use it, you could maybe just zip your main.py module and send it to people. And those people would need to have Python interpreter installed, and you could tell them how to run the program. That would work. But there is a better way, as always. Except we need a few more things to add to this application. First of all, a Python package has a specific code structure. Then you need to enrich it with some metadata and hopefully documentation. Best packages should have good documentation. You need to provide directions for the installer and upload the package to the packaging server. So this is how the structure of the package looks. You have the top directory, the root directory, then you create the directory named the same as your package. You put a file called init.py pi in that to signify to the Python interpreter that this is actually a Python package. This is not just any directory. And that's where your main.py is going to live now. In the root directory, we also have PyProject file. It has a syntax similar to YAML. And then I have a README, and my README is Markdown, but you can also have RST, you can have plain text, whatever you want. Some things that are optional, but also nice to have. You can add a changelog to your package, an authors file to list people who are working on that, a contributing guide, and requirements if you are using other packages to build this one. There is also, sometimes there can be multiple requirements files. People often split requirements into at least 2 different files, one for end users and one for developers. And that's why I have a requirements there. You put tools there such as PyTest or talks, something that you use to build and test your package. And then you would want to have a license. Let's take a quick look at the PyProject file. So this file is going to provide instructions for your package installer, the metadata about your package. Here I have name and version, author and description, also specifies where my README lives, and the requirements for the version of Python. I also say that use this specific BSD3 license, and I can specify a bunch of optional classifiers. This one only has 3. So classifiers, it's first of all, you want to know who the package is for. Then you want to know which license it's using. Sometimes it is limited to certain operating systems that it can run on. Level of maturity. Actually, you can also look at the version to kind of determine that, because, for example, if the package doesn't have a major version yet, just the minor or bug fix version, it's probably not quite ready for production use. But that's kind of not very direct evidence. Possibly you can specify some other metadata in the classifiers. So what are the package entry points? Entry points allow you to export functions out of your package so that they are visible to the outside world and the operating system knows how to run it. And also you can extend your package with plugins, but we're not going to talk about this here. I have a very minimal README here. It looks like this. I have a header and description, basically. How to package this whole thing up? So to package it up, you would have to pip install a special package called build, and then call it by typing in the console python-m build, or you can just say build. When you do that, this is what's going on. It's going to create dist directory underneath your package, underneath the root directory, and it's going to create a couple of archives in there. One of them, as you can see, is gzip, and the other is WHL. So those are 2 different distribution types. The gzip, tar gzip, it's a source distribution. And here is what's inside. Basically, it zipped up all of your files and added a couple of files that were not there before, like pkg info and sources.txt and dependency links. It just has a certain structure it has to follow, so it creates and adds its own metadata. WHL file, wheel, it's a pre-built distribution. For the Python package, it looks very similar, like for a pure Python package, it looks very similar to a source distribution. And this is what's inside that one. So why do we need two different types of distributions? The binary ones, wheels, they are usually quicker to install, even if you have a pure Python package. But especially for a package that requires native extensions. There are a lot of packages these days that have extensions built in Rust, in C, in C++, every kind of language. And for those, you would need to install a whole stack of different tools to build them on your machine. But if you have a wheel distribution, you don't need to. A wheel distribution can be targeted to a specific OS and platform, but it can also be more generic and target several different ones. And usually you see what it targets in the name of the distribution. So it has a Python tag, ABI tag, the application binary interface, and the platform tag. And the platform tag is going to be something like Win32 or a Linux version, or it can also say any or none. Then you are going to upload your distribution to the PyPI server. Here is a link to the test PyPI server, and that's where you usually want to start to make sure things are working, to just test things out. There is the real pypi.org and then the test pypi.org, and you have to register accounts on both. It's not the same account. It will ask you to verify your email when you first time use that. And then it's usually better to also create an API token for uploading your package. An API token is going to ask you the scope of your token, and you can just tell it to scope it to all the future projects that you create. Then you're going to create a file on your machine called PyPI-RC. It's a configuration file for the PyPI server. You can put your username and password in there, but that's not a good practice. A better practice is to create a token and put it in your PyPI-RC. If you do it this way, you are protected from basically hacking attacks. So if somebody steals your token, they can't do very much with it. Yes, they can upload a package pretending that they are you, but they cannot log into your PyPI account and take it away and change the password, things like that. So even if somebody happens to upload some junk package under your name, you can afterwards log in and remove it and change the password so it doesn't happen again. How do you upload this? Here, you're gonna need another Python package called Twine. Twine is the package that knows how to upload Python packages to PyPI server. Here is the command, twine upload. You provide repository test PyPI because we're using the test one here, not the real one. If you're using the real one, you can completely omit this part. And then the dist directory. After that's done, if that succeeded, you can already pip install your package. Usually the command would be just pip install my advisor. My package name is my advisor. Here I'm doing pip install and provide an index URL because this is not a standard PyPI server, right? This is a test one. I need to specify that explicitly. After you did that, you can just run it in terminal with one command name, my advisor, and it's going to display this message. Today is good for traveling. Let's talk a little bit about the license. Usually, it's better to have some kind of a license. You have to decide what you want to allow people to do with your source code. If the package doesn't have any license, it means people can't do anything. Basically, they can't copy, distribute, or modify your software. And that's probably not what you want. But this is what happens if you don't have any license in your project. Theoretically, people can't do anything. Some licenses, such as GPL v3, tell the other users that they cannot close the source. Basically, this cannot be used in like the production level closed source projects. Perhaps you don't want to be so restrictive. There are some very permissive license, like MIT license, and people can do anything they want. They can use it in a closed source project. They can use it in an open source project. They can modify the code. Often, this is what you want. Sometimes, when you write the Python code, you write within a community, and the community has a preferred license, so the choice is made for you. It's easy, you just use that. You can follow this link, choosealicense.com. There will be some good advice and a list of different types of licensing options. It doesn't provide it's a very large list, but it's not all-inclusive. There is some types of licenses that you don't see, very rare, that it doesn't have. So some other files that you might have in your package, what are they for? For users, changelog actually can be very useful. They can see every change, every bug fix, every new feature added by date and version, and they can decide which version they need. For example, they're looking for a specific feature or a bug fix. Sometimes an operating system packages, well, mostly operating system packages are not updated as quickly as PyPI packages. And so even if a person has a package that, say, is installed from Ubuntu repository, they might want to go to PyPI and install the newer version from there. And that's how they would know to even look for that version. The authors file is useful for contributors to give credit to people that work on the application. And then if several people work on the package, you would probably want to have a contributing guide. That's where you would put instructions about your environment setup, what code style you prefer to use, what kind of Git workflow, how to review PRs, how people should test this, what are your requirements for test coverage, etc., etc. Python dependencies are required for your application if the application is, or if your package is actually using them. And the ones that your application is using, you would put into requirements.txt. The ones that your developers are using, you would put into requirements dev.txt. You can create a requirements file pretty easily by just doing a pip phrase, but usually you would want to edit it by hand because it's going to output the exactly equal versions into that file. But you probably want to specify a qualifier saying that I want a version that's equal to this or higher. And then that's it. So what did it take? We wrote a little bit of code. We added some metadata. We added a license and a documentation. For me, it's just README here. We installed 2 tools build and twine. We run 2 commands, and there is no magic. The whole code presented in this demo, you can find on this GitHub link. And there are some useful links here. So the first one is a link to the slides that were presented here. And Python packaging guide. You can find all this information and more in the packaging guide. Then Python package installer and documentation about Python wheels and what they are. If you have any questions, you can contact me using those credentials, Twitter, email. And that's it. Thank you.